but there are four problems. There's one from module two, which is phase relations. That's almost completely analytical and quantitative, although it's the underlying concepts that allow you to work through a thought process of solving a phase relations problem, right? Um, One problem from module three, which was soil classification. That is highly conceptual in terms of being efficient at classifying soils. If you understand the concepts and how to understand the differences between gravel, sand, silt, and clay, where they fit in terms of, a clean granular soil versus a dirty granular soil versus a dual symbol granular soil versus a fine grained soil. If you understand those concepts, then you have worked yourself well into the analytical thought process of classifying a soil. So, of course, there's concept there, but it is analytical and quantitative in the sense that, as I said last Thursday, I'm going to give you a gradation chart, right? I'm going to give you a gradation chart of several soils. I'm going to ask you to classify several soils, each of and an average of 5 minutes or less, right? So if I give you five curves or however number curves, if I ask you to classify four soils in 20 minutes, you should be able to do that. Okay, so understanding the concepts to a deep level helps you be very um, comfortable and confident, and fast and efficient. If you don't understand the concepts and maybe you've tried to memorize some things and you're just trying to follow a flow chart, you're probably gonna go too slow getting yourself down the analytical and quantitative part of that. Okay, so one problem from module two, phase relations. One problem, of course, broken up into multiple parts, like maybe four different soils, but one problem, very similar to the homework where you were given gradation charts of multiple soils, classified these, soil A, soil B, soil C, soil D, whatever. Very similar to that, but I'm going to expect you to be much better now than you were when you first did it in module three. Okay, so again, one problem from module two, phase relations. One problem from module three, soil classification, soil types and soil classification. And two problems from module four. The first one being much more analytical and quantitative. Again, it all falls back onto the concepts and how well you understand um, how things fit together. The better you understand the concepts, the easier it will be to work yourself through the analytical thought process. Okay, but it is highly analytical and quantitative. The part of module four that we finished last week. Okay, the second problem from module four. So again, one from module two, one from module three, a sort of analytical quantitative leaning problem from module four, and then a highly conceptual, basically no analytics, no quantitative from module four. Okay. And that stuff we got into last Friday, haven't quite finished, and that'll be the focus of class tomorrow. What are those concepts about how do we compact soil? The sort of principles and analytical things were before the compaction curve and the Proctor compaction test. And then we got into earthwork quantities. Okay, that was one side of it. But conceptually, how do we do all that? And that's equipment and machinery and techniques and what kind of compaction methods. How do you match them up with certain soil types in certain soil locations? And the location is either at the surface or at depth. Okay. If it's at the surface, you're going to use a roller. And so, what kind of roller for what kind of soil at the surface? But if the soil is not at the surface and you want to improve it and compact it, there are other techniques, methods that we use that work down below the soil surface, 10, 40, 100 feet down, trying to improve and compact those soils down there. That's what we'll be talking about tomorrow. So those concepts. So again, four problems. Basically, three of them are much more highly analytical and quantitative, and one of them is all conceptual. Okay? So that's the overview, that's the outline, and I didn't bring it up on screen, although I could have. The outline for exam one is posted. Just a sort of brief outline reminder of what are the things that we did in modules 2, 3, and 4. All right, and now I've given you more detail exactly, and I can't really go into any more detail about exactly what to expect on the exam, but there it is. I will not, you will sometimes have to do a sketch, like a phase diagram, a block diagram, or maybe I'll just give it to you, but you got to fill it in. But any charts and graphs like this, like gradation curves, it's not valuable time spent on an exam to give you a bunch of numbers and you plot them on a grid. I will not ask you to create your own gradation curves or your own compaction curves. Or later on, we'll have, other curves, like consolidation curves and so forth. I will not ask you to create your own curves on an exam. That's a huge waste of time. If you have the curve, if I give you the data with a chart with a curve on it, like for example, this one right here, where did that go? This chart right here. If I give you a chart with a curve on it, do you know how to use it? This is the engineering part of things. What does the curve mean? How do you use it? How can you get information to do some analysis? Okay. But in the homework, another thing I want you to be able to do, again, not on an exam, but in the homework, I want you to work on your skills with data reduction. Reduce the data into a plot or whatever. So create the curve, create a dual axis curve and those kinds of things. More practice with Excel. I'm not going to make you practice Excel or hand plotting on an exam.
I had a question as far as like the formatting of the exam. I just wanted to make sure it's all going to be like totally free response, right? Like no multiple choice involved.
No, that's not correct. I can't say that.
Okay. So there is like a chance that some multiple choice could be sprinkled in.
Yeah, especially the conceptual type stuff. I mean, free response actually is super widely varying responses, which is really hard to grade, right? When I'm talking about concepts, many of these concepts, um, they will have answers that are pretty black and white and only have one good answer, right? And so fill in the blank, multiple choice, things like that certainly could be on there when it's a conceptual type problem.
I had a quick question. So I went over the slideshow that you had for the exam review, and I saw that you had the ASHTO designations crossed out. And are we going to only have to worry about the US designations, or are we going to also have to worry about the ASHTO designations?
Yeah, I said that last week in class. Not going to even ask you about ASHTO on the exam.
Okay, thank you.
Yep, you're welcome. Okay. Um, I want you to understand USCS. I think it's far more valuable, and if you get the concepts, then using an ASHTO chart is actually very, very easy, and not really worth my time testing you on an exam. I think the biggest thing with exam number one is that too many people in the class are usually not ready for it. And what I mean by that is that, like I said at the beginning of this session, and I said pretty much on the first day of the class trying to recommend the best way to sort of attack and prepare, um, which is consider every day that you're preparing for the exam, and certainly don't leave it until the last few nights before the exam. And that goes the same with every module and every homework assignment. Don't leave them. Do a little bit every single day because you really need to dive in. If you don't struggle, you won't learn. When you struggle and then get help, that's when you learn the most. This is what we did every single day in statics, dynamics, and deform. Um, and so usually it's the time for exam number one, much less so on exam two, and even less so on the final exam. But on exam number one, most students are surprised by how fast it goes. And that's because, well, in my opinion, you're not going fast enough solving these problems. And what I mean by that is at this point in the semester, for example, phase relationships. And I was just asked about, let's say, problem 428, for example, right? Several problems in the homework were very similar to that. Draw a phase diagram and given a little bit of information, calculate and determine all these other values. Okay. Um, um, you should be very well practiced and be very solid and confident and comfortable, knowing how to solve those kinds of problems. The whole thought process of working yourself analytically through it, through the solution process, right? And so if you're not really good, confident and comfortable and efficient, if you're only doing it for the second or third time, the first time was on the homework and you struggled through it and got some answers. And then maybe you did it a couple, once more studying for the exam, that's probably not going to be enough. Okay, you really need to work through every single step of the process to become confident you know what it is that you are actually doing. Not just memorizing equations or pulling them out of the textbook and figuring out how to plug and chug, because that is absolutely not the best way to do it. That is the worst way to do it, and probably also the slowest way to do it. Um, so be good in terms of knowledgeable, skilled, and efficient and fast in solving a phase relations problem, like several of the homework problems. Okay. Same thing with soil classification. Be skilled, be knowledgeable, understand what you're really doing so that you can be efficient, confident, and fast. Any soil in 5 minutes or less. Some soils are a little easier than others and maybe only take 2 or 3 minutes. Other soils take 6 or 7. If you can do multiple soils on an average of 5 minutes or less for each one, then you'll be in great shape. Dual symbol, probably, which I was asked about and we'll talk more about, probably takes the most amount of time. Okay, but even that one should be no more than 5 or 6 minutes. So, be skilled. The first time you did it, you were probably really unsure and very, very slow. Second, third, and fourth time, using the videos, using the example problems, coming to class and asking questions. And I said multiple times, I was really disappointed that I wasn't really getting any questions in class. And so I have to assume everybody knows it really, really well and you'll be ready for the exam. So now here we are. Okay, so this is what I'm getting at. Know it really, really well. Make sure you're not confused about anything. And look, man, having the textbook in front of you during the exam will not help. It really won't. It will hurt you more than it helps, especially if you considered that you want to use it during the exam. You can't do that because this is not about memorization. That's why I give you the textbook, so you don't have to memorize. This is about analysis and problem solving, and the textbook can't help you do that. It can just remind you of details that you may have forgotten, like exactly what is that equation? But the textbook doesn't really tell you how to use the equation unless you're going to spend like 30 minutes. reading through it and such. So time is the biggest thing. Many students um, do not finish all 4 problems in 75 minutes. As a matter of fact, they spend too much time on the first 1 or 2 problems. Many students in the past focus so much on soil classification and then do really excellent on that problem and then not so good on the next 2, and then the fourth one is completely blank because they didn't have time. So that's usually the problem with some students on exam number 1. Of course, I always have some students who finish exam 1. It's barely on time, barely on time. But some students finish with a really, really excellent and impressive score on exam 1. But, you know, most students, I shouldn't say most students, a good number of students, maybe roughly half, don't finish the exam because they spend too much time on 1 problem and they're just really not fast enough, good enough, quick enough, efficient enough to do all 4 problems. All right, so that, Aiden, that's a really good question. But also something that I sort of have described before. Specifically, which question? I can't answer that one because there is, it's all over the place. It depends on, which students. Some have mastered like compaction techniques and things better than others, and so they do really great on that one, but don't have enough time to do soil classification. Other students do excellent on classification, but maybe don't have enough time to do the phase relations. So time is the issue with exam number 1. And like I said, just because of the kinds of material that we're going to do later, it becomes bigger and more complex problems. But there's much less of a time factor, a time issue with exam 2, and even less so with the final exam. Some students finish exam 2 early. Some students finish the final exam really early. Of course, there's always going to be some students who want 20 or 30 minutes more time no matter what, right? So it's all over the board, but in general, time is the issue with exam 1.